Hi guys, this lesson is on 2.4 called the final velocity formulas. So here's a snippet from your formula sheet. We have a formula for acceleration and a formula for final velocity. First thing I want to do is point out on the formula sheet that you should have a copy of the formula for acceleration here and for final velocity here. That's what we're using for this lesson. So what do all of these variables mean? First one. This is acceleration. You can see by the fact that I put an arrow on top that it is a vector. It has a direction. It can also be a scalar if no direction is given. The top of the fraction has velocities. They both have v's, and then they have little subscripts. So like in chemistry, how we wrote the numbers really small and below the regular line of script. This stands for final velocity. This VI stands for initial. And the last one, delta T, or just T, stands for time. So let's go through and make sure we know the units for all of these. Let's start at the bottom because that's the easy one. Time, the base unit in physics is seconds. Velocities are both measured in meters per second. And if you take meters per second and divide by seconds, you get the units for acceleration. Meters per second or meters per second squared. So all of these things are going to be given to you in a word problem. You need to write down what you're given, what your question mark is, and use the appropriate formula to solve for what you want. So here's the first two formulas. Are we looking for acceleration or are we looking for final velocity? It's the exact same formula, just rearranged. And for those of you taking Physics 20, I'm going to show you how to rearrange it on this slide. If you are not taking Physics 20, you can fast forward until the next slide. So here's the first formula. I'm going to show you how we rearrange this to get final velocity by itself. The first thing we do is we want to get time up on this side. So we just multiply it over. The next thing we want to do, if we want VF by itself, is we have to get rid of VI. It's minusing, so I'm going to do the opposite, which is plus on both sides. So these will cancel, and on this side I'm left with VF. On this side, I've got AT plus VI. So there's the algebra of how we created the second formula from the first one. And that's why I say they are the same formula. All right, everybody should be back on this page, whether taking Physics 20 or Science 20 next year. And when I read through the question, remember to write the sig digs above or below the number and circle the smallest number so we know what our final answer should be. A car is stopped at a red light. The light turns green and the car accelerates. After 6 seconds, the car is traveling at a rate of 4.25 meters per second. Determine the acceleration of the car. What I should see on your pages is 3 sig digs for 6 seconds, 3 sig digs here. So we'll write our final answer to 3 sig digs. Now, there's actually 3 numbers given to you in this question, even though there's only 2 that you can see right off the bat. Reread the question and see if you can figure out the one word that actually tells you another number. If you thought that stopped was a pretty important word, you're correct. If the car is stopped to start with, What is the car's initial velocity? 0. If you're stopped, you don't have any speed. Then after 6 seconds, it ends up going 4.25 meters per second. As soon as you see that the units are meters per second, you should know that that's a speed, and you can write it down in your list. So here we go. I'm going to do all of this with scalars because they aren't giving me a direction. My initial velocity was 0. Since 0 is just a constant, I don't need to have sig digs for it. It's like saying 5 bumblebees. It doesn't factor into sig digs. 0 is just 0. So initially they're going 0. A time of 6 seconds has elapsed, and they end up with a final speed of 4.25 meters per second. And the question is asking us what acceleration is. Once you have all of your variables written, you go to your Physics 10 formula sheet and you locate the formula that has all of that stuff in it. So we had A, VF, VI, and T. The formula I've highlighted here has all of those things. I'm going to write that formula down, and I abbreviate this. I don't write final and initial out completely. That's fine. It's the same formula. This is a step you want to be careful with. Don't get lazy. Copy it down perfectly, because if you copy the formula down wrong, you have no hope of doing the algebra correctly or putting it in your calculator correctly. Now we're at the substitution step. So I don't know acceleration. I'll just leave it as A. VF is 4.25 meters per second. Now, don't get lazy on me. You need to write your units in every single step of your work here. So meters per second has to be there. Minus initial velocity is 0 meters per second over the time, 6.00 seconds. Again, units. And you have to put the 0.00 because that's significant digits. That's important for us to write. Now, how do you put something like this in your calculator? Well, those of you thinking ahead might think, when I subtract 0, nothing happens. I can just put 4.25 divided by 6. But let's do this in our calculator as if that wasn't 0. The important thing to do is tell your calculator that both of these numbers are in the top. So you're going to use the bracket buttons on your calculator and go bracket 4.25 minus 0, bracket, divided by 6. You should get the number, and it's quite a long number, 0.708333333. 3 goes on forever, so I just wrote the 3 repeating. Now, I'm writing this down just so we can learn how to do it properly. And we need to make sure that our answer is written to 3 sig digs, like we said. So here's my 3 significant digits. I only look at the number directly after those 3, so it's a 3, to see if I round. A 3 does not make me round up, so my acceleration for this question is 0.708 meters per second squared. The sooner you memorize what the units should be for acceleration, velocity, distance, time, the easier putting the units on will be. Now, you should be able to think about whether that number makes sense. We got positive acceleration. That means the car is speeding up. In this question, the car was stopped at a red light and it ended up traveling faster. So yes, the car is speeding up and a positive acceleration makes sense. If the car was slowing down, what do you think the acceleration would be? Negative. So we can kind of gauge whether our answer sounds correct or not by what sign we get. This example I'm going to skip over for COVID. It talks about how you change kilometers per hour to meters per second in physics, but we can cover that next year. The next one we're doing is the cannonball question. A cannonball is fired from a cannon with an initial velocity of 150 meters per second. It has an acceleration of negative 2.50 meters per second squared due to air resistance. Determine the final velocity of the cannonball after 60 seconds of movement. You've got the process now. First step is to write the sig digs above every number. I see 3. I see 2 down here, and I see 3 up here. So our answer is going to have to be written to the smallest number of sig digs, 2. Now, it might also help to highlight or underline what they're telling you. They're actually telling you in words what this is. Initial velocity, they're telling you it's VI. They're telling you A. They're asking you to find VF. And seconds, we all know that that's a measurement of time. So let's list all of that. Initial velocity is 150 meters per second. Acceleration is negative 2.50 meters per second squared. We talked on the last question about acceleration being negative, meaning it's slowing down. That's what a cannonball does. The air is going to make it slow down. And that negative is very important so that the numbers work out. You can't drop the negative. The time is 60 seconds, and final velocity is our question mark. So we go to our formula sheet. What formula on here has VI, VF, A, and T, and specifically is rearranged so that we can find final velocity, what we're looking for? There it is, right there. Copy that formula down. There it is. Now, I'm not working with vector arrows here because I don't see a direction on any of these numbers, but you can put vector arrows on those if they're giving you a direction, like if they say north or something, then it would be vectors. All right, substitution. Remember in physics, we sub the whole number in to proper sig digs with units. The first part here is AT. That means A times T. So I'm going to put it in brackets. I've got acceleration times time plus initial velocity. Now let's talk about this little thing right here. That is part of the units. That is saying that acceleration is meters per second squared. That is not telling you to square the 2.5. That's not what it's saying. That's just the units. Okay, so you're not going to do anything in this first little bit here except for go negative 2.5 times 60. That's all you're going to do in your calculator. Okay, and then you can add 150 after. So again, this is calculator. That's why I'm not writing the units, because that's what I want you to type onto your screen right now. But when we write the workout, we write the units in there. So here I go, putting it in my calculator. I'm going to put the bracket, negative 2.5 times 60, bracket, plus 150. Don't be afraid of the answer that you get. I got a 0 on my calculator screen. What does that mean for this cannonball if final velocity is 0? The final speed of the cannonball is 0. After 60 seconds, what is the cannonball doing? It has stopped moving. That's perfectly acceptable. Getting a 0 doesn't mean you did something wrong. It tells you what the cannonball is doing at the end of 60 seconds. Now I am going to write this number to 2 sig digs. I'm going to put the proper units for speed of meters per second and call her good. If you're getting the hang of this, you could try pausing the video and see if you can set up the question properly and then check your answer. An object starts from rest and accelerates 1.30 meters per second squared north for 6 seconds. What is the final velocity of the object? This is another example where we're given two numbers on the paper, but we're actually given three numbers from one of the words in the question. Now, it doesn't have the word from the previous question, stopped, but it does have something that means the object has stopped. It has this word from rest. If this object is at rest, that means it has a speed of 0. Its initial speed is 0. Then it accelerates. As soon as I see the units are meters per second squared, I know that that's an acceleration. And I actually see a direction as well, north. When you see those square brackets, those indicate that you're doing a direction. So all of these things are actually vectors. I can put the vector arrows in this example. Time, 6.00 seconds. Time does not have a direction, so time does not get a vector arrow. And what we're looking for is VF. This is the same formula as the last question because we're looking for the same thing. But I'm going to put vector arrows on all of the speeds and acceleration because they're actually velocities with a direction. I'm now going to sub in everything I know. Acceleration, 1.30 meters per second squared north. Time, 6 seconds, plus initial speed of 0. So really, all I have to put in my calculator here is 1.3 times 6, but we write our work properly in physics with all of the sig digs and the units. Remember that this squared is a unit, not something that you put in your calculator. If you do that calculation, you'll get the number 7.8 on your calculator screen. But we have a question here that has 3 sig digs, 3 sig digs, so it needs to be written to 3 sig digs. Your calculator will never write it to the proper number of sig digs, it just tells you the number. You have to know that this number, in order to have 3 sig digs in it, needs to have a 0 on the end. Now it's the proper number of sig digs, and the units for velocity are meters per second. And since there's that vector arrow, I've also put my direction, north. What if we were asked for time? This is actually a very simple rearranging of the original formula. If I'm asked to solve for time, and I've got something on top and bottom, that good old thing we learned in trigonometry, where these two can switch places, is all you have to do. Time would come to this side. The top of the fraction doesn't change, and acceleration would go to the bottom. This is not on your formula sheet because we need you to be able to do that algebra quite quickly. Okay, switch A and T. That's it. If you want it in words, here it is. Here's an example where we'll use that. A track athlete runs at a velocity of 8.1 meters per second, then slows down to 4.1 meters per second. Her acceleration is at a rate of negative 0.62 meters per second squared. How long did this change in speed take? Here we go. They're running at 8.1, then slow down to 4.1. What is their initial velocity? Good. 8.1 meters per second is how fast they're going initially. It's very important that you don't get initial and final mixed up. Then they slow down, so their final speed is 4.1 meters per second. Their acceleration is negative because they're slowing down, so that makes sense. And we're looking for how long or how much time this takes. Now, here's the formula that's on your formula sheet. But we just learned that you can easily switch A and T to get time by itself. So I'm going to do that. And that's the formula that I'm going to use. So here I go substituting my numbers in. VF is what I put first. I wrote it second over here, so be careful that you pick the right number. 4.1 meters per second minus VI, 8.1 meters per second, over acceleration, which is negative 0.62 meters per second squared. Remember that the squared applies to the units, not to the number. When you put this in your calculator, you have to put the top in brackets, and then you can divide by negative 0.62. So here's what I should see in your calculator. Bracket 4.1 minus 8.1, bracket, divided by negative 0.62. That's what you're writing on your calculator screen right now, with those brackets in exactly those places. All right, I am getting 6.451612903, so quite a long number. I need to write it to the proper number of sig digs, which in this question, 2, 2, 2, I need to be 2 sig digs. So I'm going to write a few of the numbers so I can show you how to round properly. If I'm going to write 2 sig digs, here's 2 sig digs, but you always round if you need to. How do we know if we round? We only look at the number right after. None of these other numbers matter. If you're using those other numbers, you're called a happy rounder because you round too many times. You should only ever round once in a question. I'm looking at the 5 to decide whether I round the 4 up. Yes, 5 and above rounds up. So my acceleration for this, or pardon me, my time for this question is 6.5 seconds. You only round that last digit up. So that brings us to the end of 2.4. The worksheet is on the website, as is the answer key. I'm easily contacted by email if you need to ask me questions or set up a video chat to do some examples together. So please don't hesitate to reach out if you need help. Bye, guys.